Okay, welcome back. Section 6.5, video number 2. So we continue with properties of logarithms. So far you guys have 8 of them, and we'll start with writing expressions as a single logarithm. So we're going to do the opposite of what we did. We're going to rewrite the expanded form to a condensed form. So here we're going to condense. We're going to shrink it, okay? Make it short. Okay. So we're going to rewrite using single log. I'm going to use the examples from your textbook, not examples, the problems. You have also examples if you like to study from the book, from the textbook. So I'm not using those examples. This is for you to study and have more examples if you need it. So I'm always selecting something different. So this is problem 57 from page 459. And they give you this 3 logs of base 5 of u plus 4 log of base 5 of v. So you need to rewrite that, you need to condense that using single log. So major operation is plus. That means eventually we will use the product property. But we're not ready for product property, okay? I'm not sure if you guys remember from last lecture, but when we were expanding, the last property which we applied in expanding was power property. When you condense, which means rewrite something long using single log, you're going to start working backwards, which means the power property is going to be the first thing what you're going to do. So with condense, note the power property is the first one to apply. Okay, so that's the first one which has to be used. So look what happened. You have number in front of log. So you're going to put that number back as a power. So you're going to use that power property. Also, you have 4 in front of the second log. You're going to move that 4 back as a power of v. So we're using the power property first for both of them. So we're working backwards here. Okay, so that will give us log base 5 of u to the third power plus log base 5 of v to the 4 power. So like you see, we put power back. Okay, now when you don't have any expressions in front of log, now we can start talking about product property. The sum of logs is equal to the logarithm of product. So here we're going to apply product property next. So we're putting this back, okay? We want to have an answer having only one log. So the sum will become the product. So you copy log once of base 5 and we multiply u to the power of 3 times v to the power of 4. So you multiply them, okay? So that will be u to the third power times v to the 4 power, and this is your final answer. So that's what we're doing here. Okay, so make sure on your homework that you read exactly the directions and instructions of problems. Here we need to write expression as a single log. So this is our final answer. Writing expression as a single log means condense, make it simple. So we doing the opposite of what we did in the previous video. Okay, let's do more examples. Number 63 from the same page. You have ln of x over x minus 1 plus ln of x plus 1 over x minus ln of x squared minus 1. So we need to simplify that. We need to rewrite as a single log. So let's start talking about this. Okay, so first of all, since you only have the plus and minus, which is the sum and difference operations, you're working from left to right. Okay, so what I recommended first, okay, start with simplifying the first two logs. So nothing in front of log, nothing in front of log here. So we don't need to worry about power property. And you have a sum. So sum of two logs can be rewrite as a single log, and we're going to multiply those expressions. So here, we're going to rewrite that as a ln, and we multiply x times x minus 1 over x minus 1 times x plus 1 over x. So the sum become product. Okay. So that was the first two logs, which we simplify. Here, this one, I'm going to rewrite it minus ln. The only thing what I'm going to do, hope you guys remember that x squared minus 1 is the same as x squared minus 1 square, which you can apply the difference of two squares formula. A squared minus b squared. I gave you that formula long time ago. So this is the same as a minus b times a plus b. So you want to factor that. So I'm going to rewrite that as x minus 1 times x plus 1. So ln of x squared minus 1 is the same as ln of x minus 1 times x plus 1. Okay, so I factor that quadratic expression. Okay, here. So let's just maybe simplify this, the first expression. So this is the same as ln, and look what happened. We have a multiplication. So you have x on the top, x on the bottom, you can cancel them. So that will become just ln of x plus 1 over x minus 1 minus ln of x minus 1 times x plus 1. So we in better situation now because we have two logs instead of three, but still the final answer has to be one single log. So now you have a difference of two logs. So difference of two logs is the same as a logarithm of quotient. Okay, so that means you're going to use here quotient property. You see the difference? That means you can rewrite that everything under one log, ln, and you're going to have a quotient. Okay, so what goes on the top? On the top goes the first expression. So we have that x plus 1 over x minus 1. Okay, quotient right here. And what will be the denominator of the quotient? The second expression, which is x minus 1 times x plus 1. Okay, so this is single log. However, we still have to simplify. It's really, I don't think my MATLAB will allow you to leave this part that way. So you have to simplify this expression. Okay, so note, simplify that expression x plus 1 over x minus 1 and everything over x minus 1 times x plus 1. How are you going to simplify? By keep, change, flip. Okay, keep, which means keep tab 1. So that will be x plus 1 over x minus 1. Change will be change this division because the major operation is division to multiplication. And flip, F stands for flip. So flip this over. So you have x minus 1 times x plus 1 when you flip it, which means reciprocal of that will be 1 over x minus 1 times x plus 1. So let me simplify. Again, I'm showing you the work on a side. We'll go back to our problem in a second. So now I'm going to multiply fraction by fraction. So x plus 1 times 1 is just x plus 1. And here I have x minus 1 times x minus 1 times x plus 1. Okay, so what's happening here? X plus 1 cancel. And that will give us 1 over x minus 1 times x minus 1 is the same as x minus 1 to a second power. Okay, so here, that huge expression right here, just move that. We're going to put it back. Okay, so that x plus 1 over x minus 1 over x minus 1 times x plus 1 is the same as 1 over x minus 1 square. So that will become ln of 1 over x minus 1 square. And this is the final answer. So again, the way I simplify this fraction, I'm showing right here. Okay, by using keep, change, flip, which means fraction divide by fraction. Okay, so we're practicing condensing, which means rewriting expanded form to logarithmic form using single log. That was 63. Let's do 68. Number 68. Again, all the problems are from page 459. Okay, here we have this 1/3 times log, and you don't see the base of the log, that means it's 10, common log, of x to the third power plus 1 plus 1/2 times log of x squared plus 1. So we need to rewrite that as a single log. Okay, so first, what we're going to do, okay, the power property is the first thing what you're supposed to do, okay, power property. So definitely here you will need to apply that power property, because when you have coefficient in front of log, that means it's a power of that expression. You put it back. Coefficient in front of log is the power of that expression. So power property. So first apply power property. Move it back. Move that power back. So that will give us log of x to the third power plus 1 to the power of 1/3 plus log, common log, x squared plus 1 to the power of 1/2. Okay, so we move that power back. Why are we doing that? Because now there's nothing in front of log, and you see that sum. So you're ready to use the product property. Product property. Sum of logs is equal to the logarithm of product. So we're going to rewrite that as a single log, common log, and we're going to multiply those expressions together. Okay, so we have x to the third power plus 1 to the power of 1/3 times the second expression, which is x squared plus 1, 1/2. Okay, and now the only thing, again, we undo things which we were doing before. So here, when you have that exponent as a fraction and when you condense, you want to rewrite that as a radical. Okay, so what's going to happen? Under radical, you put in that x cubed plus 1. Okay, 1 stays with them inside of the radical. 3, it's always the index of the radical. So we have a cube root of x to the third power plus 1 times, and I'm going to do the same thing. This expression, which has been raised to the power, which is a fraction, I'm going to convert it to the root. Okay, so we putting x squared plus 1 under the root. 1, which is numerator, it's always stay with that expression, which is go inside the root, x squared plus 1. 2, which is the denominator, it's the index of the radical. So that means we have a square root. And of course, let's just rewrite that correctly. So we have log cube root x cubed plus 1 to the power of 1 is just x cubed plus 1 times square root, again, when the index of radical is 2, we don't write that, of x squared plus 1. And this is the final answer. So don't forget that we, in previous lectures, we were expanding this. Okay, so when you condense, you're putting this back together. Okay, that's why those powers, which are fractions, you're changing to radicals. Okay, more properties of logs. Okay, so it's a lot in this section, I do understand, and I'm going very slow. Okay, properties of log. More. Okay, so let me put it, because you already have 8 more properties of logs. Okay, so the first one will be one-to-one property. You apply one-to-one property with exponents, and we're going to do the same thing with logs. If logarithm of base a of m is the same as logarithm of base a of n, then what that means? That means that this expression has to be the same as this expression. Then m, it's equal n. Okay, let me give you an example. Logarithm of base 2 of x equal logarithm of base 2 of 4. So since we have logarithms of both sides with the same basis, that means x has to be the same as 4, then x is equal 4. Okay, we're definitely going to use them by solving equations. And another one, if m is equal n, then you can always attach logs to both sides. Okay, so you can attach logarithm of base a of m, and that will be equal to logarithm of base a of n. Also, very important to solve the equations. So, example, when we're going to use it. Let's say you need to solve something like this. E to the power of x, it's equal 5. Okay, and we'll talk about them soon. So how I can solve that? I don't know how, but the base of this exponential, it's e. So what makes sense here? I can attach ln to both sides. And why I pick ln? Because natural log has a base e, the same as my exponential. So again, it's not just attach any type of log, the one which makes sense. Okay, so I'm going to attach ln to both sides. I copy this example, e to the power of x equal, and I'm attaching ln to 5. So I'm using that one-to-one property. Okay, now I'm showing you something what we're going to study very soon. Okay, why I attach ln? Because look what happened. The base of ln is the same as the base of my exponential expression, so they will cancel, and we will end up with x only. That means x is equal ln of 5. So we're using the one-to-one property to solve the equations. Okay, so like you see, e to the power of x is equal 5. How you can solve for x? Okay, so we're doing the inverse. The inverse of exponential is logarithmic. So we change to logarithmic expression. And the easiest way is just by attaching logs to both sides. Okay, next is change of base formula. I'm pretty sure that you guys heard about that. Change of base formula. In this class, you need to use that formula because you're supposed to use the basic scientific calculator, okay? So we're using this formula, so use to evaluate logarithms which base is neither 10 nor e. Don't forget that your calculator, okay, has only two buttons, okay? You're going to see log on your calculator, okay? So you don't see that base. So what that means, this is common log. The base is equal 10. And your calculator also has ln, which means the base is e, okay? So base 10, that's our common log, and base e, this is your ln. So what about if you want to evaluate log of base 2 of 7, okay? How are we going to do that? We're going to do that using change of base formula, okay? So the major formula is this. Log of base a of m is the same as a quotient of log and let's say you need new base. So I'm going to put new base, b it's a new base, of the same expression of m over log new base, and here the expression will be the old base, a. Okay, so a old base, b it's a new base. Okay, so let me give you an example. So this is change of base formula. Example, log base 2 of 5. So I want to evaluate that. So 2, it's my old base. I want to rewrite that using 5, which will be new base. Okay, so this is how I'm going to do. I follow the formula. Fraction. On the top, it's going to be log of my new base, which is 5, of this expression. Okay, over log of my new base 5, and here what's going to be the expression? It's going to be that old base. Okay, so that's how we change the base. And again, why pick 5? Because technically I can simplify that. They will cancel. That will give you 1 over log base 5 of 2. Okay. Okay. But let's just simplify that a little bit. Note, because all calculators have only ln and log, log. Again, ln. Don't forget that this is natural log. And base is equal e. Log, if you don't see the base, this is common log with base equal 10. So our calculators only have those two. Okay, so I'm going to rewrite. So to change the base, we usually use ln or log, common log. So I'm going to rewrite this. Log base a of m is the same, let me use the ln, as ln of m over ln of the old base. Okay, so this is what we're using a lot, changing to natural log, or you can use common log. Log base a of m is the same as common log of m over common log of your old base, which was a. Okay, so this is what we usually use on a calculator, since we only have two buttons for logarithms. Let me show you how to use it. Example, use the change of base formula. Okay, and this is number 71 from page 460. So you need to evaluate that on a calculator. You have logarithm base 3 of 21. So how am I going to do it? I'm going to use natural log. So I'm going to rewrite that as ln of 21 over ln of 3. And on a calculator, you would just type ln 21 divided by ln of 3, and that will give you about 2.771. Okay. Let me do number 73. So it's up to you if you want to use ln or common log. Okay, you pick the one which you like. This is logarithm of base 1/3 of 71. So here I'm showing you how to change the base using common log. So I'm going to pick log of 71 over log of old base. And you just plug in that in a calculator. Again, log, that means common log. The base is 10. When you plug in that into your calculator, you should end up with negative 3.880. Make sure you check that. We definitely using change of base formula in word problems. And 77, change the base. You have log, the base it's pi, which is about 3.14 of e. Okay, beautiful number. Only letters, okay? So I'm going to use ln for that. So this is the same as ln of my original expression over ln of the old base, which is pi. And on a calculator, you just type ln of e divide by ln of pi. And your answer should be 0.874. Okay, so that's how you use the change of base formula. Now, I want to go back from previous lecture. I want to go back to number 23, and I told you that we were not ready for that problem because we didn't know the change of base formula yet. Page 459. So they want you to simplify. And here the hint will be use change of base formula. So when you simplify now logarithmic expressions, you definitely can use change of base formula. Use change of base formula. There's not all with mathematics, there's never one way to get to final answer. So keep that in mind. Use change of base formula. So that will be the hint. I think there are two problems similar to this one. So you have log base 2 of 6 times log base 6 of 8. So what I'm going to do here, I'm going to rewrite. So hint for this one, and I really like this problem. I will put a star, a little more challenge because we need to think a little bit here. Hint, rewrite log base 6 of a using change of base formula. Pick new base equal what? Equal 2, because the previous example, the previous log has a base 2. Okay, so log 6 of 8 is the same as logarithm of base 2 of 8 over logarithm of base 2 of the old base. Okay, so now I will go back to this problem and I will put that right here. So we have log base 2 of 6 times, And log base 6 of 8, we're going to rewrite as log base 2 of 8 over log base 2 of 6. Don't forget that logarithms are the real numbers. So this is the real number, this one and this one. So the same expression on the bottom, the same on the top, cross them out, cancel, and you only end up with log base 2 of 8. Let's simplify that better. This is the same as log base 2, and 8 is the same as 2 to the third power. So base and exponential base are the same. That will cancel, and we end up with 3. That's the answer. Okay, that's it from section 6.5. Okay, thank you for watching, and good luck with studying. Stop recording.